So hi guys, welcome back to my channel Bit Explosive. In the last videos we have discussed about what hash functions are in detail, and we have discussed about the properties of hash function, random oracle. Basically, just to give you a one-liner of each of the topics that we have discussed previously. What hash functions are? Basically, we use hash functions in the blockchain. Each of the block is having the hash of the previous block. Hash functions are used to generate the hash, which we use in the blockchain, which works as a unique ID, and they are responsible for making the blockchain tamper-proof. Because if I try to tell you the structure of blockchain. And we have done this in the previous video as well, because basically how blockchain is that each of the block is having the hash of the previous block. In this way, each block is connected. And I have to tell you why this property is there, why we are linking each of the hash of the previous block, and because it just to create tamper-proof data structure. Because if any of the data is modified, hash will modify, and the blockchain will break from that part. As you will be able to know if somebody is trying to hack the blockchain. Another thing which we have discussed about is the random oracle. Basically, random oracle, it is basically an idealized theoretical hash function. This hash function is not present in the real life. If we provide some input to this random oracle, what it will do is that it has a table. It will check that input. If it is present in the table, then it will give the output corresponding to the input. Otherwise, what it will do is that it will create a new random number, and it will assign that input to that new random that is generated, and it will add it to the table. So in this way, random oracle works. If you want to know in detail how random oracle works, you can see my previous video. In that, I have covered random oracle in very detail. We have just discussed about some properties of hash function as well in the previous video, so you can watch my previous video for that as well. Now today's topic will be properties of hash functions. Basically, what we want to discuss is the cryptographic hash functions. So we will discuss today's topic will be cryptographic hash functions. We will discuss the properties of cryptographic hash function and what cryptographic hash functions are. The basic properties that we discussed in the last video for generic hash functions are held by the cryptographic hash functions as well. So what those properties were? Number one property was the input that we are giving to the hash function can be of any size. So if this is the input, if this is the hash function h, so the input that we are giving to this hash function can be of any size. So it can be 10 bits, 100 bits, 1000 bits, 10,000 bits. So it can be of any size. Another property of the hash function that we have studied was the output should be of fixed size. Basically, let's say n bits. Just to give you a brief, for SHA-256, this is a cryptographic hash function that we use in Bitcoin. So SHA-256 is a hash function that we use in Bitcoin. For that hash function, n is 256 bit. Basically, what that means is that the output of SHA-256 can be of only 256 bit. This is one thing. And the third property that we have discussed about generic hash functions was that the generating output from input. Basically, generating output from input basically means if we are providing an input to a hash function, and generating output should be very efficient. It should not take much time, or it should not be very computational step. It should be very easy step. These are the three basic properties, and these three properties are held by cryptographic hash function as well. But there are few more properties that a cryptographic hash function should have. These cryptographic hash properties are: number one is collision resistance. Collision resistance is the first property. Another property is hiding, and the third property is puzzle friendly. These are the three properties which are the cryptographic hash function properties, and we will discuss them in very detail because this is the basic of Bitcoin. When we will discussing about Bitcoin, these properties will come into picture. So we have to understand these properties in very detail. Let's start with the first property, which is the collision resistance. What basically collision resistance means? So just to give you a formal definition, what collision resistance means is that, let's say we have a hash function h. So hash function h is said to be collision resistance if it is infeasible, computationally infeasible. Just mark this word, computationally infeasible. So if it is computationally infeasible to find two inputs, let's say x1 comma x2, condition being x1 is not equals to x2 such that the output is same. Basically, the formal definition I've given you, you can note it down for reference. But basically, what do we mean by whole definition is that, say, let's say there is two inputs, x1 and x2, they should not have the same output. Basically, this is the whole meaning of this collision resistance property, because we will be using hash functions to create a unique ID, and we don't want that we are giving two inputs and the outputs of both are the same. This is what collision resistance basically means, that we should not have two inputs having the same output. We have used the word computationally infeasible. Why we have not used the word like impossible? Why it is we have not given the definition like it is impossible to find two inputs having the same output? The reason being is that for a hash function, let's say we have a hash function. Now the output space which is there means the output which is generated will be of the order 2 to the power n basically. I have told you in the previous video itself why we are using 2 to the power n. Let me discuss that in all that also. We are saying that output space is 2 to the power m. The reason being is that, let's say our hash function is of size n, or so the number of bits in the output, let's say it is of n bits. Now the thing is that let's say n equals to 2, it means we can have 2 bits of output. So input can be of any size and output will be of 2 bits. So now each bit we can give like 0 or 1. Here also 0 or 1. There are two possibilities at the 2 bits. So we can say like two possibilities. Basically it is like 2 to the power 2. Basically 2 is n, so 2 to the power n. So this is the output space. So in this way we calculate the output space 2 to the power n. Now let's go back to our topic. We were discussing about why we can't say that it is impossible to find collision. Why we are saying computationally infeasible. The reason being is that if you see any of the hash function, the output space is limited. Basically it can have only n bits. So the output space will be 2 to the power n. Now the input, what about the input space? As we have discussed about it previously as well, the input can be of any size. It can be of 10 bits, 100 bits, 1000 bits. Our input space is infinity, because it can be of any size, and output space is fixed. Let's say 2 to the power n. Now input is of any size and output is fixed. Then it means that there can definitely be some collisions, because the output space is fixed only. 2 to the power n outputs can only be possible. Now the thing is that we are saying computationally infeasible because, let's say if anybody is giving all the power, all the computation power in the world, then also it will take around trillions of years to find a collision. So basically that means that it is computationally infeasible to find a collision in a well-defined hash function which are having the properties of a random oracle. But the thing is that in the real life, all the hash functions that we are having in real life are deterministic. Let's say if I take an example of MD5. MD5 was a hash function that was used previously for a large scale. Now people have found out that there are collisions present in that. So that's why we have moved to SHA-256. For which finding a collision is much harder. But just to be generic, if a function is a well-defined hash function, it is having the properties of random oracle, then it would take around trillions of years to find a collision in that. Now let's analyze a collision for random oracle. Now we said that it is computationally infeasible to find collision. So let's take the example of random oracle, analyze the collision in that. It is feasible or it is infeasible, how much time it will take to find collision in random oracle. Okay, this will be our topic. Our topic will be analyzing collision in random oracle. As per the definition, random oracle, what is a random oracle? Random oracle is a idealized theoretical cryptographic hash function. So basically, thing with the random oracle is that whenever we give a new input to a random oracle, it will always generate a new random output. So let's say we are giving x1, it will produce the output y1. If we are giving it x2, it will produce y2, and these y1, y2 will be completely random. So this is the property of this random oracle. And if we provide something like x1 again, then it will check the table which is present as a random oracle. Basically a table is present, it will check that y1 I have already computed for it, so it will provide us y1 if we provide x1 again. So in this way random oracle works. Basically random oracle is the idealized hash function. That means it will surely generate the random value. So now what we wanted to understand is that how many inputs we need to give the random oracle to generate a collision. So that's how many inputs we should try so that we can get a collision in random oracle. Let's say in random oracle we are generating an output for a new input, like let's say the output space is 2 to the power n. So what we are doing is that we are flipping the coin 2 to the power n times. So 0 to 2 to the power n minus 1 times we are flipping a coin. Let's say heads is 0, tails is 1. In this way we are flipping a coin and we are filling up these places to generate a random number. Let's say in first time 0 comes, in second times 1 comes, again 0, 0 till and 2 to the power n times we are flipping a coin, and this is a random number which is generated. This is y1 generated. Now how many times we should try, how many input we should give again, that the output which we are getting is same as the output that we have got previously. This is basically the meaning of collision. The same output we are getting for different inputs. So x1 and let's say this is x10,000, x1 and x10,000. These are two different inputs, and we are getting the same output. So I am just taking a number 10,000. It can be any number, and we need to analyze in after how many inputs we will get a collision in random numerical. To find a collision in a number of inputs that we need to try to find a collision in random numerical, that is to do with something like a birthday paradox. We have to first understand what birthday paradox is to understand the question that we have asked. How many inputs we have to try to get a collision in random numerical. Okay, but what is birthday paradox? So let's say there are m number of pupils in a room. Okay, there is a room, there are m number of people present. Now what is the probability of getting two pupils having the same birthday? This is known as the birthday paradox. So really the thing is that let's say analyze the output space first. Now the output space is not 2 to the power n, it will be 365 days. So, we are excluding the leap year and all, so there can be 365 possibilities. We have 365 days, so the total output space is 365 days. So now what we need to find is that what should be the value of n, so that the probability of two pupils having the same birthday is non-negligible. The probability of two pupils having the same birthday becomes roughly half, or what you can say that the probability of having two people having the same birthday becomes non-negligible if m is basically greater than or equal to 23. So if there are 23 people in a room, then there is a very high chance that the two of them will be having the same birthday. Now if you want to have some mathematical number, researchers have analyzed this and they have come to a conclusion that we need to try approx order of root 2 to the power n inputs to get a collision. This is the thing. We have to try roughly, let's say we have spaces of 2 to the power n. We have to roughly try halfly to get a collision. Order of root 2 to the power n we have to try. So what we have discussed till now is that we have to try order of root 2 to the power n times to get a collision for the inputs. Now let's take example of SHA-256. For SHA-256, n is 256. So how many inputs we have to try? Order of root 2 to the power 256. That basically means to get 128, which is basically a very large number. So we have to try these many times to get a collision in SHA-256. Now SHA-256 we are considering it as a random oracle. That is the probability of getting a collision for random oracle SHA-256. For in real life, there is no guarantee that the SHA-256 will never have collision. There can be a possibility that in future somebody finds out that there are collisions in SHA-256 as well, because as you are already aware that the hash function, the real life hash function which we are having are basically deterministic and they are not generating a random value. Okay, so there can be possibility that the SHA-256 in future can have collision. In that case, we will be in trouble and Bitcoin will be in trouble because SHA-256 is used in Bitcoin. But the thing is that in cryptography we consider that there are few functions like SHA-256 which are having the properties of random oracle and they will basically not have collision. So this is the consideration that we do. But there is always a gap between this information because there is a gap between the real life hash function and the random oracle. So we can't guarantee this, but we consider it like that. Now the thing is that we exploit this collision resistance property for defining the unique IDs in blockchain. Basically we use it for the hash of the blocks, or we use it for the hash of the transactions. These are the two applications using collision and resistance property of cryptographic hash functions. So till in this video we have discussed in detail about what collision resistance is, which is basically a property of hash function. Now two properties are pending from our side. Number two is which will be the hiding property. Another thing is, which I have told you before, as a puzzle friendly. These two properties we will try to cover in the next videos. And thank you and have a nice day. Please subscribe to my channel Bit Explosive, and we will meet in the next video. Thank you.